finish in just over 2 years to deliver these 2 satellites, and we're super excited to see them go into space today.
And tell us more about Boeing's partnership with our shared customer, SES.
So SES and Boeing have had a long-standing partnership, and the launch of the 2 satellites today, SES-20 and 21, bring the total to 15 that Boeing's delivered to SES. We are very proud to be able to bring our high reliability platforms, our advanced payload technologies to serve SES and the customers and missions that they serve. They're a global leader in satellite communications, from broadcast video all the way to network communications. We're extremely excited about today's launch and excited about the things that are ahead for us. Go SES, go Atlas, go Boeing.
Earlier this week, SES Satellite's Chief Development Officer and C-band leader Christoph DeHauer visited the launch pad. Let's take a look.
Cape Cañaveral, Florida. Behind me, there is a ULA Atlas V rocket carrying 2 satellites, 2 Boeing 702 SP satellites, SES-20, SES-21, and I'm looking forward to see those up. Launches are always emotional, but this one is really, really special, given the importance of the C-band program, not just for SES, but for the entire country. So really, there will be a lot of emotion when we see this thing up. SES-20 and SES-21 are 2 identical satellites. They are C-band satellites covering the US. They are part of a very important program of clearing the C-band in the country. So with those 2 satellites, we will be able to continue to make progress on clearing the lower 300 megahertz of C-band as mandated by the FCC in order to enable the deployment of 5G across the country. And at the same time, migrating customers in the upper 200 megahertz so that the customers can continue to enjoy the same level of services as they've been enjoying so far. I'd like to express my deepest gratitude for the team that has been working on this. The ULA, the Boeing, the SES team members, they've all done a fantastic job in delivering this program in the middle of a pandemic. Thanks a lot to all of you guys. Go SES-20, go SES-21.
An Atlas V 531 rocket is launching the SES mission. This is the 96th Atlas V flight and ULA's 154th launch. Here's a look at the rocket and events leading to launch.
Built in ULA's 1.6 million square foot production facility in Decatur, Alabama, the Atlas V rocket, once fully stacked, stands 196 feet and weighs nearly 1.8 million pounds fully fueled. At the base is the Atlas V Common Core booster, powered by an NPO Energomesh RD-180 engine. For additional thrust at liftoff, 3 Northrop Grumman solid rocket boosters, or SRBs, are attached to the rocket. Atop the booster is the ULA Centaur second stage, powered by an Aerojet Rocketdyne RL-10 C-11 engine. The spacecraft are encapsulated inside a protective 5-meter diameter payload fairing, produced by Beyond Gravity in Decatur, Alabama. With production complete, the rocket travels from Alabama to Cape Canaveral on ULA's rocket ship. Once in Florida, a series of events lead to today's countdown. The process begins by lifting the 107-foot booster onto the Mobile Launch Platform, or MLP. Next, we mate the SRBs. Then the Centaur second stage is transported to the pad and lifted into position. Lastly, the payload fairing, with the spacecraft encapsulated inside, is lifted and mated to the Atlas V rocket. Once fully assembled, the launch countdown begins by moving the rocket from the Vertical Integration Facility, or VIF, to the pad. To complete this move, which spans about 1/3 of a mile, the rocket is transported by the MLP. Weighing in at approximately 2 million pounds, the MLP supports the rocket and contains air conditioning, electrical, and commodities lines. Throughout the 20-minute trip, rail cars lead the move, with the payload van providing spacecraft communication and the ground van providing support for the rocket. At the rear of the convoy is an environmental control system, which provides air conditioning to the payload and the rocket. Trackmobiles power the nearly 3 million pound convoy. With the rocket on the pad, the launch team then transitions to fueling and other final preparations.
Atlas V will deliver SES-20 and 21 to a near geosynchronous orbit. Here's how we'll get there.
Generating a combined liftoff thrust of nearly 1.8 million pounds, the RD-180 engine and 3 solid rocket boosters ignite to start ULA's Atlas V rocket on its trip to orbit. Shortly after liftoff, the 1.7 million pound Atlas begins a pitchover to attain the proper flight path while minimizing the dynamic pressure the rocket experiences during flight. Within the first minute of flight, Atlas reaches Mach 1, the speed of sound. Within the next 2 minutes of first stage flight, the Atlas V rocket will jettison all 3 GEM 63 solid rocket boosters and will then more than double its velocity. Once the rocket has climbed above the densest part of Earth's atmosphere, the payload fairing is jettisoned. With the majority of its propellant expended fighting against the force of gravity, the main engine shuts down, followed by release of the booster stage. The rocket now weighs a little more than 10% of what it did at liftoff. To deliver the twin SES-20 and SES-21 satellites to near geosynchronous orbit, Centaur will perform 3 engine burns. Fueled by liquid hydrogen and liquid oxygen, the first burn takes the spacecraft to a LEO parking orbit. Following the first main engine cutoff, Centaur performs a short settled coast and turns to the second burn attitude. The second burn powers the trajectory onto a geosynchronous transfer orbit with a maximum altitude in the geobelt. Following a multi-hour coast, Centaur comes alive for a final burn as it prepares to release the SES satellites into near-circular, near-geosynchronous orbit at an inclination of just 1.9 degrees. Prior to spacecraft separation, Centaur enables a minimum residual shutdown to complete the final burn, utilizing all onboard propellant reserves to achieve the final orbit. This capability allows Centaur to extract every ounce of performance available. More than 5.5 hours after liftoff, Centaur releases SES-20, followed nearly 40 minutes later by the release of SES-21. From their delivery to near geosynchronous orbit, both satellites will require only minimal raising to their final orbital position and rapid activation of commercial broadcast services.
With today's launch, we're remembering teammates who are no longer with us. Let's learn more.
Today's flight is dedicated in memory of Henry Gines and James W. McAnally. For 7 years, Henry Gines served in the Navy as a systems organizational tech and earned the Sea Deployment Ribbon with a Bronze Star for good conduct. Henry then joined McDonnell Douglas's Tycho missile plant in 1987, where he proudly continued his work in national defense by helping with the assembly of Tomahawk cruise missiles, and later, the very successful SES-2 ejection seat program. Henry later moved on to supporting missions on Delta and Atlas rockets as an accomplished mechanical technician. Outside of work, Henry was passionate about sports, spending his time coaching softball and football teams of all ages. Henry was loyal, dedicated, and always joined his team with a great attitude. He will continue to be missed by his friends and family and his co-workers. Jim McAnally served as president of Martin Marietta Astronautics and later Lockheed Martin during the acquisition of the Atlas and Titan Centaur programs from General Dynamics. Under Jim's leadership, the Atlas and Centaur production lines were moved from San Diego to Denver. International Launch Services was created to sell commercial Atlas rockets. The Atlas V was developed and his team successfully negotiated the first RD-180 engine. Jim put his heart and soul into his work, and his legacy lives on in today's Atlas V.
We remain in the planned 30-minute hold as we continue towards liftoff. In a few moments, launch conductor Ron McKee will poll the launch team for the final go to pick up the count. 20 engineers and managers are polled for system status and readiness to proceed. This is the final status check for all Atlas vehicle systems, ground systems, spacecraft, and the U.S. Space Force Eastern Range. The vehicle system readiness poll includes electrical systems, hydraulics, pneumatics, propulsion systems, flight control, and propellants. Let's listen in as Ron McKee performs the final polling.
L minus 7 minutes.
Status check to proceed with terminal count. Atlas systems, propulsion.
Go.
Hydraulics.
Go.
Pneumatics.
Go.
LO2.
Go.
Water.
Go.
Centaur systems, propulsion.
Go.
Pneumatics.
Go.
LO2.
Go.
LH2.
Go.
Pass gas.
Go.
Electrical systems, airborne.
Go.
Ground.
Go.
Facility.
Go.
RFFTS.
Go.
Flight control.
Go.
GCQ.
Go.
Operation support.
Go.
COM. Umbilicals.
Go.
ECS.
Go.
Red light monitor.
Go.
Quality.
Go.
Op safety manager.
Go.
ULA safety officer.
Go.
Vehicle system engineer.
Go.
Anomaly chief.
Go.
Range coordinator.
Clear to proceed.
Launch director.
You have permission to launch.
Proceeding with the count. ALC verified T0 set for 21:360.
Verified.
Polling is complete. The ULA launch team is go for launch. From T-minus 4 minutes until launch, you'll be listening to Ron McKee and his team performing the final steps in the countdown procedure. Several critical activities occur in the final minutes before launch, including verifying fuel tank and pressure levels in both the Atlas booster and Centaur upper stage, while also arming the flight termination system. At T-minus 25 seconds, you'll hear Go Atlas, Go Centaur, Go SES. This is the final status check of Atlas, Centaur, and SES readiness. At T-minus 3 seconds, the main engine ignites, followed by ignition of the solid rocket boosters. Then, after seeing Atlas V lift off the launch pad, you'll begin hearing the flight commentator Jesse Gonzalez providing launch vehicle ascent data. This is Atlas Mission Control at T-minus 4 minutes and holding. We anticipate releasing the hold in just a few moments.
Mark of the time will be T-minus 4 minutes and counting. 3, 2, 1, mark. T-minus 3 minutes and 55 seconds.
Ground pyros enabled.
The countdown clock has resumed, and we are go for launch at 5:36 p.m. Eastern. With liftoff approaching, we're going to raise the volume on our launch team so you can hear the final preps taking place.
T-minus 3 minutes.
T-minus 3 minutes and counting. Op number 057.
Securing LO2 topping. 250.
Atlas tanks to flight pressure.
FPS internal. 159. Vehicle internal. 155.
Launch sequencer start.
150. Securing Centaur LH2.
Securing Centaur LO2.
140.
Launch enabled.
137. FPS armed.
T-minus 90 seconds. The launch vehicle, payload, ground systems, and eastern range are go for launch.
120. OCUs armed.
FCS count started.
115.
Reduce ECS for launch.
Roger. 110.
Send valves blocked.
T-minus 1 minute.
T-minus 1 minute.
Range green.
seconds.
Stable at step 3.
Verify ECS reduced for launch.
Verified. 25.
Status check.
Go Atlas.
Go Centaur.
Go SES.
T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. And liftoff of the United Launch Alliance Atlas V rocket, carrying SES-20 and 21 for SES, the leading provider of global content connectivity solutions.
After 15 seconds into flight, the EU has gone to closed loop control. Coming up on 30 seconds into flight, RD-180 is throttled back as expected. Engine response looks good.
You're hearing the voice of Jesse Gonzalez providing launch vehicle send data.
And 40 seconds into flight, Atlas V is now supersonic. And the vehicle is now passing through max Q, maximum dynamic pressure. And the RD-180 is now throttling back up as expected. Engine response continues to look good. Passing a minute into flight, continuing to see good SRB chamber pressures. RD-180 pump speed and fuel injector pressures are responding well to demands on the engine. Vehicle is continuing right down the middle of the range track. And we have good burnout on all 3 SRBs. Standing by for SRB jettison in about 20 seconds. And we have good jettison of all 3 SRBs. And the vehicle has gone to closed loop guidance. And the RD-180 is throttled down as expected. Engine response continues to look good. About 2 minutes remaining in the boost phase of flight. The vehicle is now 45 miles in altitude, 70 miles downrange, traveling at 5,500 miles per hour. Passing 3 minutes into flight, the RD-180 is throttling down again as expected. Engine response continues to look good, and the RCS system is now pressurizing to flight levels. And about 1 minute remaining in the boost phase of flight. And we've had good indication of payload fairing jettison and Centaur forward load reactor jettison. And the RD-180 is now throttling up as expected. Engine response continues to look good. And the RD-180 is now throttling to maintain a constant 4.6 G acceleration limit. And Centaur has begun the boost phase chill down sequence to thermally condition the RL-10 for operation. Standing by for BECO shortly. And we've had BECO, booster engine cutoff. And we've had Atlas Centaur separation. And seeing good pre-start on the RL-10. Standing by for MES-1 shortly. And we have ignition for the first burn of today's mission. This will be the first of 3 Centaur burns for today's mission. It will last a little over 7 minutes. RL-10 operating parameters and vehicle body rates are looking good in the first part of the burn. Vehicle continues down the middle of the range track, now at 120 miles in altitude, 500 miles downrange, traveling at about 13,000 miles per hour.
This is Atlas Mission Control at T plus 5 minutes 45 seconds. We just heard flight commentator Jesse Gonzalez confirm the successful completion of the early phase of today's flight, and all systems continue to operate nominally. Our next event, Centaur main engine cutoff, will occur in about 7 minutes. During this time, I have the pleasure of welcoming ULA's Commercial Program Director, Vernon Thorpe. Thanks for joining us, Vern.
Thanks, Ryan. It's a pleasure to be here.
Cool. So, we just lifted off on a long ascent to orbit. What should we expect to happen over the next 6 hours?
Okay, well, we just saw the initial booster ascent phase, so now what we're going to do is 3 Centaur burns to complete this mission. The first burn is happening right now, of course. That'll last about 7.5 minutes. When that is complete, we'll enter a 12-minute parking orbit coast, and then we'll have a second Centaur burn. That Centaur burn will last about 5 minutes. And that will place us into a geosynchronous transfer orbit. So the highest point of that orbit will be up at geosynchronous altitude. So after 5 hours, when we're at the top of that elliptical orbit, we will do another Centaur burn. It'll be just over 2 minutes long, and that will essentially circularize the mission. And at that point, we'll be very close to a geosynchronous orbit. We'll take out most of the inclination during that burn as well, and we'll go from about 28 degrees down to about 1.9 degrees of inclination. Following that, we'll separate the satellites. We're going to separate the satellites 40 minutes apart, and that'll be centered around the T plus 6 hour mark, so one about 20 minutes before and 20 minutes after that.
Very nice. And why might a orbit matching Earth's rotation be necessary for these satellites, SES-20 and 21?
Well, that's the advantage of a geosynchronous orbit for many communication satellites. You know, at that altitude, the time that it takes to do one orbit of the Earth matches the time it takes for Earth to rotate once. So from an observer on the surface of the Earth, it looks like the satellite is stationary in the sky. So since you have that fixed relative position, that's very convenient when the satellite needs to provide continuous communication coverage to antennas on the Earth.
All right. So next question for you. Following separation from ULA Centaur, SES-20 and 21 will be operational fairly quickly. What more can you tell us about that?
Well, they'll be operational very quickly because of that near geosynchronous orbit that we're placing them into. Typical GTO type mission where the spacecraft has to do the orbit raising up to geosynchronous. For a satellite like this, for these two satellites, it would take about 5 to 6 months because they have electric propulsion systems, they're very low thrust systems, so it takes a long time to achieve the final orbit. With this mission today, we're going to put them almost exactly where they need to be for their final operational orbit, so it cuts out most of that orbit raising time, and it'll allow them to get both spacecraft, SES to get both spacecraft operational about 5 months earlier than if we had flown a traditional GTO mission profile.
Very nice. All right, so that leads to our Atlas rocket has quite a legacy of support to commercial satellite missions. Tell us a little more about some of the missions we've put in orbit.
Sure. So both Atlas and Delta, the rockets we fly at ULA, have been launching commercial satellites since the early 1960s. In fact, we launched what many consider to be the first true commercial communication satellite, and that was the Telstar mission that Delta launched in July of 1962. And that was such a big deal at the time that it actually inspired a hit song that year. It was recorded by the Tornadoes. That was 1962. After that, for the first few decades of our business, we launched a lot of commercial satellites, but our customers had to work through either NASA or the Air Force at the time. In the mid-1980s, that changed. There was the Commercial Space Act, and there was other legislation that allowed users to work directly with U.S. launch vehicle companies. And since that time, we've launched hundreds of missions, a lot of commercial missions, missions for NASA and the Air Force as well. But really, since the 1960s, Atlas and Delta have really helped lay the foundation for the entire commercial space industry. And Centaur was originally designed for high-energy, highly accurate interplanetary missions, but our commercial customers have taken advantage of its capabilities as well.
Very nice. I'll have to give Telstar, was it?
Telstar, yeah.
Telstar a listen. So commercial missions will be a big part of ULA's future. Can you give us a look ahead?
Yeah, since Atlas and Delta came together to form ULA in 2006, we've had about 15% of our missions have been commercial launches. That's going to ramp up to 50% over the next few years, and that will include geosynchronous communication satellites like we're launching today. It'll include commercial missions for NASA, crew, and cargo, and of course the Kuiper satellites for Amazon as well.
All right, well, thank you for joining us today, Vern. Appreciate having you on.
Okay, my pleasure, Ryan. Thank you.
This is Atlas Mission Control at T plus 11 minutes 33 seconds. We are now approaching the end of the first burn of the Centaur second stage. Let's listen in as we approach this next event.
And standing by for MECO shortly. And we've had main engine cutoff. RL10 shutdown signatures look good. And the RCS system is now commanding 100% settling.
This is Atlas Mission Control at T plus 12 minutes 26 seconds. Jessica Gonzalez has reported successful cutoff of the first of 3 Centaur engine burns. The SES-20 satellite is scheduled to separate from ULA's Centaur upper stage into a new near geosynchronous orbit in about 6 hours, followed by SES-21. Once we sign off in a few moments, you can stay updated on today's long ascent to orbit with ULA's live blog at ulalaunch.com or join the conversation on Twitter and Facebook. I'd like to thank Jesse Gonzalez for his participation in today's show. I'm Ryan Gendoli. We'll take another look at liftoff, which occurred at 5:36 p.m. Thanks for joining us. T minus 10, 9, 8, 7, 6, 5, 4, 3, we have ignition. 2, 1. And liftoff of the United Launch Alliance Atlas V rocket carrying SES-20 and 21 for SES, the leading provider of global content connectivity solutions.
Program. Passing 15 seconds into flight, PU has gone to closed loop control. Coming up on 30 seconds into flight, RD-180 is throttled back as expected. Engine response looks good.
You're hearing the voice of Jessica.